hello everyone. So first of all, thanks for attending this session. So how Kissflow break down silos, unified data strategy. And this is Adi Ramanathan. I am heading the platform engineering at Kissflow, and we are based out of Chennai. Okay, I'd like to start with a question. So how many of you started the journey with SQL system? You, okay. And anybody moving from NoSQL to SQL? Okay, probably we are one among them. So we started our product journey in way back 2012 with the Google App Engine and the Google Cloud SQL as a backend database. And today I'm going to talk about what impacted us to move, led us to move to the HTAP system. So in the first part of the session, I'm going to talk about the our journey and what are all the learnings and what are the challenges that we faced to move to the new system. And the next session, next part, I'm going to cover our new unified architecture with the HTAP database. Okay, let me give a brief introduction about our product, Kissflow. Kissflow is a no-code, low-code platform primarily focused on citizen development, and we empower citizen developers to build applications without any coding or any IT assistance. So they can build applications on their own. And it's a multi-tenant architecture, and it's a SaaS. We are offered this as a SaaS model. So the next few slides, I'm going to display some of the screenshots of our application, of our product, which are developed using our platform. This is to give you a glimpse of what the product can do, right? So this is the purchase order application, a screenshot of the purchase order application, and this is going to be used by the end users. This is to basically capture the form data, okay, the runtime form data. So this is a developed application, and yeah, and this is a form builder. This is a very important module because the purchase order form which I displayed in the previous slide was developed using this form builder. And as a platform company, we empower developers to create their own version of the form. So what it means, if a same purchase order application is going to be developed by another customer, it may not be following the same structure. It could be different. As you can see, we have various types of fields displayed in the left-hand side. So we can just drag and drop and create the your own version of a form. And what it technically means, the schema is completely dynamic. So the schema is completely dynamic, and it's unique for every customer and every applications, right? And this particular feature allows them to create their own version and more customized forms. And one more point is they can create this type of application in few hours to 1 or 2 days. So that's our power of the platform. And it's not just with the creating application, we also allow the customers to create their reports. So we pretty much support all type of reports, start from the list, charts, and the bar, all sort of reports. And we used to take care of creating the indexes as well, right? So these are all the capabilities of the product. Let me take another example which we all can connect, okay? So to organize this type of event, right, that HTAP event, the PingApp team or any other event organizer, they have to take care of multiple tasks, right, to perform, to conduct this event successfully. So right from handling the registration and providing accommodation for the speakers, or arranging food, or arranging the auditorium and everything. So they need to take care of multiple tasks, right? So with Kissflow, we can build an application to manage this type of a task effectively. And what's more important is, if another company is going to create trying to build an application for this type of event, it may not be same. It could be slightly different because they could follow a different process, different form, but still the core functionality is same. So we have like thousands of customers, each customer is having hundreds of applications, and each of their applications are unique. So now you just think about the number of schema definitions that Kissflow handle. So that level of schema definitions we internally handle. And what's more important is like the change management. The application is not going to be the same. The people will keep on changing their application according to the need. So we take care of managing the changes as well. So for example, I create an application with 4 or 5, 10 form fields. Tomorrow I will add some more fields, and tomorrow I will change from data type from string to number or number to date time. So we take care of change management as well inside the platform by ourselves. So that's pretty much about our platform. So now let's get into the technical aspects. So for this type of platform, these are all the DB requirements that we need. First, obviously, it should store the transaction data, right? And the next one, it should store the application definition, which is the metadata of all the applications, right? And we should be able to run reports like join queries and things like that. And the third one is it should provide a live data access to the customer. Okay, probably I'll touch upon this a bit more. As a platform company and as a SaaS platform, we own our customers' data, right? Some of our customers are expecting us to provide a live database access to access their data. This is to build more complex reports using some third-party BI tools. So for that, they need a live access to the data, because the reports that we provide may not be sufficient for them to build their whole vendor. So that's why they need a live data access. So we need this particular support. And finally, the data should be on the cloud. So these are all the DB requirements. All right. So in the initial version, everything was good. So what are all the challenges that we faced? The first version, we followed multi-instance architecture, whereas every customer will be dedicated with a dedicated SQL instance. Okay? And as you can see, whenever a new customer signs up for the product, we have to provision a new SQL system. And whenever a customer cancels their subscription, we have to clean up those systems. And this model pretty much worked well in the initial times, but when our customer base increases significantly, we started facing problem. Because every now and then we have to create and deprovisioning the SQL systems. So within a few years, we started managing thousands of SQL systems. We have to, it's not just provisioning and deprovisioning, it's also we need to take care of providing, if we have to roll out any system schema changes, we need to roll out to all the thousands of instances. And similarly, if we have to put any security patches, we have to take care of all those things. So to govern this infrastructure, we have to build additional layer on top of it. So these challenges made us to look for a new solution. So we just want to come out from this multi-instance architecture. So with that, in 2018, we completely re-architected our platform by having a document-based NoSQL as the backend and as the primary database for the transaction data. And we used data warehousing for the reports and analytical needs. So the reason is, we felt that document-based NoSQL is an ideal solution for our storing our application definition, because that's a flexible schema. And we thought we could use the same for the transaction data as well. But unfortunately, the NoSQL is not that rich in the join table queries, right? So we have to, but join is essential for our customers, for reports and analytics. So we have to use the data warehousing just to provide the reports and the analytical needs, and also the live data access. And this is how the system we built with the NoSQL and the data warehouse. As you can see, we capture the transaction data, whatever the data I showed in the previous slide, right? Like the purchase order form. So that data we capture in the NoSQL system. And we built our own ETL job to synchronize the data from the NoSQL to the OLAP system. And from there, we built our reporting modules. So the reports and analytics modules will run on top of the data warehousing platform. But the challenge here is we have to write our own ETL. Unfortunately, we couldn't find any ready-made ETL which is available in the market. The problem is our schema is completely dynamic and it is not static because every customer will have their own versions of their application. So we don't have a ready-made ETL tool. So we have to write our own ETL. That's where the problem started. The problem is obviously the time, okay, the latency. The data synchronization time from the NoSQL system to the OLAP system takes like somewhere from a minute to an hour. Most of the customers build their dashboard using our reports module, but they expected that reports should be synchronous, right? It shouldn't be like there shouldn't be any delay. So the problem is whenever a user submits a request, it should get reflected immediately in the live dashboard, but it won't happen because the nature of the ETL, it will take time to synchronize the data. So that is one of the challenge we faced with the existing approach. And the second one is obviously the maintenance, because we again faced we spent significant time to stabilize that ETL job because of the dynamic schema and other things, right? So we felt a significant challenge in the maintenance as well. So considering these challenges, we had to look for a new solution, and that's where we evaluated HTAP solutions. And we felt only a single database can solve both our analytical and transactional needs. Then we after evaluating few HTAP databases, we finalized with TiDB. So this is our new system. So we have HTAP as a single database for transaction and the analytical data. But the thing is, we haven't completely eliminated the NoSQL from our system platform, because we felt NoSQL still remains the ideal for our metadata, because that's dynamic in nature. So we still have the NoSQL system along with the HTAP database. So we built a unified interface to support these both systems. Okay. So this slide shows a higher level architecture of our new system. So we built a common unified session interface which is exposed to the rest of the platform module. As you can see, the workflow, reports, metadata service, user service, all these services will hit a common interface, because these services doesn't need to worry about the underlying implementation of the database. They use the common interface for any type of queries. And we have a unified data mapper which takes care of routing the queries to the appropriate system, whether if a workflow service or a report service issues a query, that will be directed to the HTAP system, whereas if a service request is coming from the metadata service, and that will be routed to the NoSQL system. And beneath that, we have an SQL session. In that SQL session, we use PV as an object ORM, which is an object relational mapping. Again, for ORM, we dynamically generating the model, because again, due to the dynamic nature of our platform, we cannot generate the models statically. So we generate models on the fly. And to generate the model, we retrieve the definition from the NoSQL system, because the application definition is stored in the NoSQL. So we retrieve the definition and we generate the model, and through that we operate in the HTAP systems. So this is the high level overview of our new system. So with that, I'm concluding this session with these points. So we're still facing some like the hosting charge with the new system is slightly on the higher side, but still we feel that it's justifiable, because we can completely eliminate the latency with a minimal effort. So that is also very important, because we don't want to again spend maintenance on the ETL job and all. And what is more important is we were able to provide a better user experience for the end users. So that's all from my side. So thank you.